So, our next part of understanding quadrilateral is kinds of quadrilaterals. The first type or kind of the quadrilateral is a trapezium. Here, A, B, C, D, similarly P, Q, R, S. These two figures are of a trapezium. A quadrilateral having only one pair of parallel sides. Only one pair of parallel sides is called a trapezium. We know that the quadrilateral have two pairs of opposite sides or two pairs of sides, AB and DC, the first pair, AD and BC, the second pair. Here, AB and DC is the first pair, and the first pair means these two lines, these two sides, AB and DC, they are parallel to each other. In the second figure, PQ and ESR, these are the two parallel sides or parallel sides, means one pair PQ and ESR is parallel to each other, while PS and QR are not parallel to each other. If we produce ES, similarly RQ, then we see that the side SP and RQ, they are intersecting, and therefore these two sides are not parallel to each other. Here AB and DC, these are the parallel. We know that if two lines are there, and if we draw a transversal, if we draw a transversal, then these angles, these two angles, they are interior angles, and interior angles are always supplementary, means sum of these two angles is 180 degree. Here, if we draw another transversal, then this angle and this angle, these two angles are supplementary because they are transversal, and if we remove this part of the segments, then we will get a trapezium. In this way, here angle A, if we give here name A, B, C and D, then we see that angle A and angle D, they are supplementary. In sum of these two angles is 180 degree. Similarly, angle B and angle C, they are also supplementary. Therefore, angle B plus C is equal to 180 degree. Here, these two lines are parallel. PS is the transversal, then angle P and angle S, they are interior angles formed due to the transversal of the two parallel lines, and therefore P plus S is equal to 180 degree. Similarly, angle Q and angle R, they are also supplementary, and therefore sum of these two angles is 180 degree. Therefore, angle A plus angle D is equal to 180 degree. Similarly, angle D plus angle C is equal to 180 degree. For the second figure, angle P plus angle S is equal to 180, and angle Q plus angle R is equal to 180. Isosceles trapezium means a quadrilateral or a trapezium in which one pair of opposite sides is parallel, while the non-parallel sides are equal, and such a type of trapezium is known as isosceles trapezium. Here the two lines are parallel, and if a transversal is drawn, another transversal is drawn, and if these two non-parallel sides are equal, then equal angles to the parallel sides. Means here angle S and angle R are equal. Similarly, angle P and angle Q, they are equal. Here angle P plus angle S is equal to 180 because they are interior angle. Angle Q plus angle R is equal to 180 degree. They are also interior angles, and therefore sum is 180. Here angle S and angle R, S and R, they are equal. Similarly, angle P and angle Q are also equal. Now we will see the second type of quadrilateral, that is known as kite. A kite is a quadrilateral which has both pairs of adjacent sides equal. The diagonals of kite are perpendicular to each other, but only the shorter diagonal is bisected by the larger diagonal. Here PQRS is a kite in which the pair of adjacent sides, means PS and PQ, these are the adjacent sides. Similarly, RS and RQ, these are the adjacent sides, and therefore PS equal to PQ. Similarly, RS is equal to RQ. Here PR and SQ are the two diagonals out of which one is shorter and the another is larger or longer. Here shorter diagonal is bisected by larger diagonal PR. So this is the main property of the quadrilateral kite. Third type of quadrilateral is a parallelogram. A parallelogram in which both pairs of opposite sides are parallel is called a parallelogram. A quadrilateral in which both pairs of opposite sides are parallel. Here A, B, C, D is a parallelogram. Why? Because side AB and its opposite side BC, they are parallel to each other. Similarly, side AD and its opposite side BC, both are parallel to each other. Means both the pairs of the quadrilateral ABCD are parallel to each other, and therefore ABCD is a parallelogram. Now we have to see properties of a parallelogram. So very important point this is, because to solve the examples we must apply the properties. Means the problems are based upon the properties of the parallelogram. So we will see the properties one by one. First property is, in the definition of the parallelogram, that is a quadrilateral in which both the pairs of here opposite sides are parallel. Means the first property is that opposite sides of a parallelogram are parallel. So this is very important property. Then second property is opposite sides are equal. Means opposite sides of parallelogram are parallel as well as they are equal in length. Means length of AB equal to length of DC, or length of AD equal to length of BC. So opposite sides are equal in length. The third property is opposite angles are equal. Opposite angles are equal. Here angle A and angle C, these are the opposite angles. Similarly, angle B and angle D are also opposite angles, and therefore angle A equal to angle C and angle B equal to angle D. Fourth property is the adjacent angles are supplementary. Adjacent angles, angle A and angle B are adjacent angles. Similarly, angle A and angle D are also adjacent angles, and therefore angle A plus angle B equal to angle A plus angle B is equal to 180 degree. Similarly, angle A plus angle D is equal to 180 degree. Here angle B plus angle C is equal to 180 degree. Similarly, angle C plus angle D is equal to 180 degree. The fifth property of the parallelogram is very important. The diagonals of a parallelogram bisect each other. The diagonals of the parallelogram only bisect each other. There is no word perpendicular bisector, only bisector is there. Means parallelograms bisect each other, they are not perpendicular bisector. In some cases they are perpendicular bisector, we are going to see later on. But in a parallelogram the diagonals are bisector of each other. Here we will see one example which is based on the properties of the parallelogram. Here RUNS is a parallelogram. The example is given that in the figure RUNS is a parallelogram. Find x and y. Here in the figure RUNS is a parallelogram. SU, similarly RN, both are the diagonals of the parallelogram. Here this is y plus 7, this is x plus y, this is 20, and the length of this is 16. Now to solve this example or to find the values of x and y, here we have to write that RUNS is a parallelogram. We know that the diagonals of a parallelogram bisect each other. Means y plus 7 is equal to 20. Similarly, x plus y is equal to 16. Means both the values are equal, because we know the property that the diagonals of the parallelogram bisect each other, and therefore y plus 7 is equal to 20. Here y plus 7 is equal to 20 implies if 7 is taken to the another side, it will become minus. So y is equal to 20 minus 7, and 20 minus 7 it will be 13. So y is equal to 13. Now we have to see that x plus y is equal to 16. Here x plus y is equal to 16 implies here we have to substitute the values of y, that is x plus 13, y is equal to 13. So x plus 13 is equal to 16, and therefore x is equal to 16 minus 13, and that is equal to x is equal to 3. In this way we can solve the various type of examples which are based on the properties of the parallelogram, and therefore you must learn all these properties of the parallelogram. Some special parallelograms. The first parallelogram of special type is rhombus. A rhombus is a parallelogram having all the sides equal. Means if all the sides of a parallelogram equal, then it is known as a rhombus. Here A, B, C, D, is a parallelogram in which all the sides are equal and they are denoted by equal marks or same mark. A, C and B, D are the diagonals of the rhombus. They intersect each other in a point O. But very important property of the rhombus is that both the diagonals, they are perpendicular bisector of each other. Means AC is perpendicular to BD, and therefore this angle, all these angles are 90 degree at the point of intersection, and therefore angle AOD, angle BOA, that is equal to 90 degree. Now this angle BOC, COD, they are 90 degree. So let us see the properties of rhombus. The first property is that opposite sides are parallel. So this is the property of parallelogram. Just now we have seen all the sides are equal. This is also the property of the parallelogram. Opposite angles are equal. Then adjacent angles are supplementary, and very important property that the diagonals of the rhombus are perpendicular bisector of each other. That is, diagonal AC is perpendicular to diagonal BD. Also, since they are bisector of each other, so therefore the length of OA equal to length of OC. Similarly, length of OB equal to length of OD. Therefore, we have shown here that OA equal to OC and OD equal to OD. So this is the very important property of the rhombus. And now we will see the second special type of parallelogram, that is a rectangle. A rectangle is a parallelogram having all the angles 90 degree or all the angles right angles, and therefore angle A equal to angle B equal to angle C equal to angle D, and that is equal to 90 degree. Here all the angles are shown 90 degree. Here AC and BD both are the diagonals of the rectangle, and mind well that both the diagonals are equal in length. Means the length of AC equal to length of BD. Here the properties of right angle are: first, opposite sides are parallel, then opposite sides are equal in length, then third is all the angles are right angles, just now we have seen, then both the diagonals are equal in length and they only bisect each other. And therefore, if O is the point of intersection of both the diagonals, then OA equal to OC and OB equal to OD, and therefore these are the properties of the right angle. There is one more special type of parallelogram, and that is square. A square is a rectangle with equal sides. Means it is a rectangle. We know that a rectangle is a parallelogram, and therefore square is also a parallelogram, and therefore it obeys all the properties of the parallelogram. So let us see the property of a square. First property: square is a parallelogram. Second, its opposite sides are parallel. Then all the sides are equal in length, and each angle of the square is 90 degree. Both the diagonals are equal in length, and both the diagonals are perpendicular to each other, and therefore here right angle is shown. So they bisect each other in a 90 degree. So these are the properties of the square. In this way, we have completed our topic, understanding quadrilaterals.